All right, this is part 2 of lesson 7.1. Again, the objective is to write ratios and solve proportions. Quick review. Pause now if you want to try it and then check back with your answers. All right, so we're going to use some properties of proportions. Some of these you may remember, some you may not. But whenever you have two ratios that are proportional, we can write an equal statement. And that equal statement can be written in several ways. One, we can use the cross products property. And we know that A times C is equal to B times, A times D is equal to B times C, as long as B is not equal to 0 and D is not equal to 0. And some new terms, A and D, are known as the extremes, and B and C are known as the means in that proportion. And those terms you'll better understand them by the end of this chapter. Anyway, so B times C here, so AD equals BC. And there's some equivalent forms. We can rearrange those proportions in a couple different ways, and they'll still be equal. So, and notice in this one, we're just flipping each fraction, and that's proportion property 1. Property 2, we're taking the top two and writing those as a ratio, and that's equal to the bottom two as the same ratio. Notice the A and the B are both from the same original ratio, so they're both numerators, and the denominators come from the second ratio. Then one other one, we could add the base to both, and we'd still have a proportion. So, all right, so the means are, in this case, they're the 3 and the 4. And the extremes are the 2 and the x. So, which property do we have here? In the first one, we're just flipping over the fractions. That is proportion property 2. Oh, sorry, we're not flipping over the fractions. We are using the numerators. We are using the first ratio as the numerators. Okay, and number 11, that's the cross products property. Number 12 is property 1. That's where we just flip each one. And number 13 is property 3. Proportion property 3. Maybe we'll call it PP1. And so on. Okay, so let's use some of these ideas here in a problem. A pygmy rattlesnake has an average length of 18 inches, while a western diamondback rattlesnake averages a length of 5 foot 6 inches. What is the ratio of the length of the pygmy rattlesnake to the length of the western diamondback rattlesnake? All right. Let's see here. So one thing that we need is we need the same units of measurement. So this one is in inches and this one is in feet and inches. Now you could do it either way. You could change the pygmy rattlesnake to feet, or you could change the western diamondback to inches. So I think I'll do that. 5 feet 6 inches. is equal to 12 inches per foot, plus the extra 6 inches, so that's 66 inches. And now I can write the ratio of the pygmy rattlesnake. So that comes first to the length of the western diamondback. So 18 to 66. And we can simplify that also. Both of those numbers are divisible by 6. So we could divide both those by 6. And we get 3 to 11. We could also write it as a fraction, like that, 3/11, or we could write it using the colon. So all those give us the ratio of the pygmy rattlesnake to the length of the western diamondback. All right. Pause here if you want to try it. All right, problem 2, the measures of two complementary angles are in the ratio of 1 to 3. Complementary angles are two angles that add up to 90, so let's say we have that. And the ratio of the angles are 1 to 3. So just think one is, so let's say this one is x, we don't really know it. If the ratio is 1 to 3, then that means this one here is 3 times as long as that one. And so together, the two add up to 90. So we get 4 times x is equal to 90, and really that makes sense. So we have 4 parts. One part, so this is like a part to part right now, but if we make it a part to whole, then this angle is 1 out of the 4 total parts. And this angle is 3 out of the 4 total. So that makes up 1/4 of the total, and that makes up 3/4 of the total. So if we take that 90 and divide it by 4, we get one of those parts, which is 22.5. And if we multiply that by 3, then we get the other angle. So that is 3 parts, and that's 67.5. And if we add those two numbers, they add up to 90. All right. Go ahead, you can try it with this one. Check back with your answer if you want. Actually, I'll help you with this one. We really have a scalene triangle here, because the ratio of the parts are 2 to 4 to 5. So that means that there's 2 parts for one side compared to 4 parts, another side compared to 5 parts of the third side. So if I think of x as 1 part, then the shortest side is 2 of those. So I can call that 2x. The next longest side, we'll say maybe it's this one, is 4 of those x parts. And then the last side is 5 of those x parts. And then perimeter is just adding up the parts, the 3 parts of the triangle to get the total. And 2 plus 4 plus 5 is 11. Remember, x is just one of those parts, so when we solve for that, we get 7. And the longest side would be the one that has 5 of those parts. So 5 times 7 is 35, our answer. And you could check the other ones by finding the other 2 sides. The one that is 2x would be 2 times 7, which is 14. 4 times 7 is 28, and of course 35, and all of those need to add up to 77. All right, go ahead and try it here. Check back with your answers. All right, problem 4. What is the solution of each proportion? All right, we're going to use the properties, and this one I think we'll use cross products property. So if we multiply the extremes, 3 times x, that will equal the product of the means, which is the 8 times the 5. So 3x is equal to 40. And if we divide both sides by 3, we get 40 divided by 3, which is 13 1/3. For the second one, same deal. If we take the product of the extremes, that's these two, 6 times quantity y plus 3, that is equal to the product of the means, which is 12 times 5, which is 60. So if we divide both sides by 6, we get y plus 3 equals 10, and y is equal to 7. All right, problem 5. In the diagram, x over 10 equals y over 9. What ratio completes the equivalent proportion y over x equals blank? Use one of the properties of proportions to justify your answer. All right, so our proportion is x over 10 equals y over 9. And if you look back at the proportion property, you will notice that we can write these two as a ratio, and they will equal these two as a ratio. And that is the, let's just call it one of the proportion properties. I think it's number 2, but as long as we know it's one of those. All right, circle the means, underline the extremes. The means are equal to 3 times 4, which is 12. The extremes would be 7 times x, which is 7x. The error is they did not multiply the means together and the extremes together. They multiplied the 7 and the 4, which can't do that. So let's just say they multiply the wrong parts. And if we do this correctly, we get 7x equals 12, so x equals 12 divided by 7. All right, see you tomorrow.